Thank you.
Thank you. If you don't know who I am, I'm really sorry, because this talk's actually mostly about me. So I'm tomnomnom, and I make tools. And in fact, I love tools. I really love them from the bottom of my heart. So a bit of expectation management for you. I'm going to talk about. I'm going to talk about how I got started, how I think you can make good tools, some questions I get asked a lot, some stuff I just kind of think about a lot, really. There'll also be some stock photography and emojis, because I love all of those things, and some questions. I love questions. Hopefully, we get some time for questions. So what even are tools? It's a question I think about kind of a lot. I think it's basically anything that augments your ability to do things. Something you can't do as a human, and there's something that helps you do that. Crows use tools. Crows are cool. But like mechanical tools, software tools, they're all the same. I love them all. Click. I love them for as long as I can remember. So this is me, 4 years old, with a hammer. And if you have children, you will be terrified by that idea of a 4-year-old with a hammer, I'm sure. My parents were pretty good for that. My 4th birthday, I got a tool set, and I took apart literally everything that had screws in the house. Didn't matter what it was, took it apart. So it's something that started really early. And like I said, the thing I really love about tools is they make you literally superhuman. Things you can't do as a human without tools, you can do as a human with tools. I got my first taste of computing when I was about 8. About 1994, I had a computer that looked like this thing that my parents got, and I remember the specs like the back of my hand, because I was obsessed. The 486 DX2, 66, 4 meg of RAM, 512 gig hard drive, ran Windows 3.11. I loved it. I tried to do like QBasic and that kind of thing with it. I never really got very far, but I also kind of broke it in tinkering it. Didn't have the internet, so I spent a lot of time figuring out all of the things it could do by myself. And breaking it actually taught me the most about computing at the time, because I had to fix it before my dad got home from work, because it was expensive. He would have been pretty upset. And a lot said about how computing has advanced in terms of like how much memory you've got, how fast CPUs are. And like, that's cool, but I think actually one of my favorite things about how much things have progressed is this is the screen resolution of that computer embedded inside the screen resolution of my current screen. Let's swap hands. Like, I can't even read that. That's crazy. When I got a little bit older, I got my own computer instead of just a family computer. Duron 1.3. It was amazing. I actually had access to the internet as well, which was fantastic. And when I was really young, I always said I wanted to be an inventor. In particular, I wanted to make robots. I really loved the movie Short Circuit with Johnny Five. So that was my inspiration. I want to go and make machines. But the problem with that is that machines and motors and things like that are expensive, and it's a constant source of expense. When I discovered software, I found something where I had one tool, just the computer, and no raw materials, but I could still invent things. I started out on Windows, like basically everybody did at the time, and it was as awful as you might think. I later tried to move on to Linux because I thought that would make me cool, which is the least cool thing that anybody has ever thought, I think. This is my actual desktop from the time, running on Slackware Linux, which I downloaded over a period of days. I actually, before that, tried out this thing called QNX because it could install onto an image file on a FAT32 partition, and that meant I didn't have to like reformat and mess around with bootloaders and that kind of thing. But at the time, we had AOL, dial-up internet, and it did not work with QNX. So I went through this process of boot into QNX, try and do something, fail, reboot into Windows, connect to AOL, find the answer, hopefully, write it down, print it out, reboot, try it again. So I ended up trying to experiment more than reading documentation as much as possible. When I got to high school, I found this website called trytohack.nl. And I thought it was incredible because hackers are cool, right? and you get this series of hacking challenges. I think now you would call it a CTF, but at the time, I hadn't heard the term. CTF was a thing in Quake, I think, at the time, where you actually capture a literal flag. And I never beat the final level, because you had to do some C compilation, and I only had Windows, and it didn't work, and I was too confused. But that was sort of my early introduction to hacking, was stuff like that. I also, like many of you maybe, got into trouble at school. Because we had computers, but they have restrictions. You couldn't right-click. For some reason, they decided it'd be very dangerous if children using computers should right-click things, so they disabled it. So I wrote a reg file to reset the restrictions. And in the UK, what in America they call roll call, we call the register. Now, my teachers got the wrong idea when they heard that I had changed the registry and thought I'd changed the register, and I got into really rather a lot more trouble than I probably should have done. So what is a hacker? Obviously, it's someone who looks like this, if you ask stock photo websites. But really, I think it's someone who finds ways to use things that already exist in a way that the designer didn't intend, especially if it's a way that the designer explicitly did not want you to do. To me, that's what makes somebody a hacker. I got into bug bounty after I'd been a software engineer for about a decade or so. I was writing software and most all PHP stuff, and it was okay. And my employer launched this bug bounty program, and for whatever reason, they decided it was going to be staff taking part, which I think is pretty unusual. I feel really lucky that I found myself in that situation, because here I was presented with a way to make some money out of a system that I knew really, really well, because I'd been working on it for a number of years already. I was hooked. Couldn't stop me from doing it at all. But I had a bit of a problem, which was there was a lot of stuff to look at. I needed tools, so I need to make tools. And I think making tools, for me, is the ultimate display of affection for tools. Someone who has always loved them, the absolute best thing you can do is to make them. And that's particularly cool because when you're making yourself superhuman, you get to pick your own superpowers. So it's not like a lot of the TV shows where you may be mutants and you don't get to choose. You get to decide. Like, I'm going to augment my own abilities somehow. Also, it's fun. You might hear people say, don't reinvent the wheel, but sometimes you need a really specific wheel. And for me, the first problem I came up against is I went and Googled hacking tools or something like that and found Burp Suite. And I found it intimidating. I looked at all of those tabs. What is a pitchfork or a battering ram? I have no idea. And for me, as a software engineer and someone who was used to making things, it was actually somehow less intimidating to go and make my own tools instead of learning to use somebody else's tools. Now, I think GUIs are great for discovery, and you can click around and all that kind of thing. But I'd spent most of my career in the command line at this point. So I went and wrote command line tools, which, as an aside, if you have command line tools you want to use and you use Burp Suite, check out the Piper extension, because you can make it pipe requests and responses into command line tools. Which is a good tip. There will be a few tips here and there. Now, the first tool I wrote was one called Meg. And Meg is a tool for requesting lots of paths against lots of different servers. And the reason I wrote it was because of that thing on the right. That's a picture from where I worked at the time. They had graphs of everything. If there's a spike in requests, someone actually looks at it. They notice it. And I wanted to not let them know that I was sending quite so much traffic as I was. So I wrote this tool to do it. And I would do things differently if I did it again, which we'll talk about in a bit. But that was where it started for me. There was tools out there that seemed designed well for pen testers, but not really anything for bug bounty, because nobody I talked to at the time had even heard of bug bounty. I did particularly well on that program. I was really lucky. I got invited to some live hacking events. Got like an NVH belt thing, which was absolutely surreal. But before that, I didn't really know anybody else. I assumed everybody else doing this stuff was going to be doing it in a similar way to me. And then I met this guy, a live hacking event, my good friend Stuck, who's down here. And he was like, hey, I want you to show me some of your tools and how you use things. We'll do a video, completely unscripted. And I was like, sure. Rattled off like how I was doing things, didn't think much of it. And then the video went live, and I found out I was wrong. And not everybody was doing things that way. People were using Burp Suite. They weren't using their own custom tools. And I think there was a phrase I used in that video about 8 times, which was, I actually have a tool for that, that I've written. It kind of became a catchphrase throughout that video. And I'm told, I struggle to sing my own praises a little bit, that had a decent impact on the state of bug bounty tooling, and this way of having small Unixy tools that do one thing, do it well, and talk to each other. So, the tool-making process, as far as I'm concerned, looks roughly like this. The first thing is to have a problem. A lot of people I've talked to speculatively try and think of something to write a tool for. They say, hey, what tool should I write? And I think that's the wrong way to start. The first thing you should do is, I have a problem that I can't solve. And then you should do the most simple thing that you can think of to solve that problem, which is usually something like a complicated command line one-liner. Then sometime later, you may encounter that problem again. If you don't, probably don't need to write a tool for that. If you do, go back to your previous solution, improve it, and then repeat. And I think one of the critical things for me is when you encounter a new problem, you should make a new tool. Don't go back to something that is close, but not close enough. You end up with this situation, which is, I'm stealing a quote from this guy, Thomas Limoncelli, I think that's how you pronounce it, and I'm going to read it for you because he's a smart dude. The problem seems to be, this automation was written to be like Ultron, and not like Iron Man. Iron Man's exoskeleton takes the abilities that Tony Stark has and accentuates them. Ultron, on the other hand, was intended to be fully autonomous. It did everything and was basically so complex, when it had to be debugged, the only choice was to destroy it. So I think of Ultron tools as these like do-it-all tools. And don't get me wrong, I think there's a place for them, and they elevate the lower bounds of security for the entire industry. I think they're great. But they're kind of boring, and money is nice, but I'm primarily in this space because I enjoy it, because I want to do things. And pressing a button and then maybe getting a result later isn't very fun. I prefer Iron Man tools to Ultron tools. And for me, I think this quote really sums up the way I think about this kind of Unixy tooling. Perfection is achieved not when there's nothing more to add, but when there's nothing more to take away. And it also means as an author of tools, I actually finish writing them, which is very nice. If you're always looking for more things to add, you are never finished. Now, a part of that is making tools that work well together, that compose well. And for me, the quintessential thing that they need to do is read their data on their standard input and output some machine-readable data on the standard output. And that enables a really nice situation where two tools written by two different people who never met can work together. And I think that is beautiful, literally. One of my best tools, I think, is a tool called a new. So it adds lines to a file, to a text file, if they don't already exist in that file. Spoiler alert. There we go. And it's short. It's a simple program. It's like 100 lines of code. And it's not even a security-specific tool. But I'm consistently hear from people, you know, my favorite tool of yours is a new. One of my worst tools, in contrast, is Meg, one of the first things I wrote. So it takes a list of paths and a list of hosts, and it requests that path for all of the hosts in a way that minimizes the traffic to individual servers, at least in any given time period. And technically, it does one thing, and it does it kind of well. but doesn't play nice with other tools. Like, if you don't want to do that exact thing, it's useless. So I replaced it with two separate tools. A tool called com, which takes two text files and does that nested while loop thing that you can do that way, but it's kind of annoying. Makes the input as Meg would have it, and then a separate tool called FFF, the fairly fast fetcher, which just requests URLs and gives you the ability to do things like only save if the responses are 200. Now, the outcome of this is the same. I've achieved the same thing. The difference is I wrote two much more simple tools, it's less code in total, that are useful on their own. If I have a different source of URLs that comes from like Wayback URLs or Get All URLs or something like that, I can use that to fetch them. I can't do that with Meg. I think it's important to note, though, that when you're pursuing these ideals, it's important to remain pragmatic. By which I mean, people will talk to you about purity and, oh, well, that's not the true Unix way. And the example I always come up with is this tool I wrote called Gron. Gron takes JSON and outputs these greppable statements for exploring the structure of the file. Now, Gron has a built-in HTTP client, so you can fetch JSON from URLs, because that's where they usually are. Technically, it doesn't need one. You could use curl, or you could use some other tool to fetch the response and pass it to Gron. But what I found was a lot of people were using this tool on Windows, where that's not actually very useful. Or a lot of people just don't know this particular syntax. I think it's important to be kind to your users and make their lives easy, even if it means breaking those supposed rules that you had in place before. So, this is my secret. You want to write tools. Basically everything I've ever written in Go starts like this. This is a Go program which opens the standard input, reads it line by line, and then you do something with each line. You would think that at some point I would have made like a template for this, but I type it out every time. It's part of the process. It gives me time to think about what I'm going to do next. But genuinely, 99% of things start this way. I think when output gets complicated, there is a temptation to make it more human readable. And I'm going to argue that you should, maybe not, you should make it more computer readable. So a format that seems to be gaining traction is JSON lines, where you have one JSON object per line. And I tend to process those with JQ if I know what the structure is going to look like, or Gron if I don't. So I'm a heavy advocate for that. Your tool should have help output. People will not know how to use your tool. You should show them how to use it. And not just list the parameters, but please, please have examples in your help output. The number of times I've looked at a new tool, run it with -h, and found it didn't respond to -h, and had to be --help instead. And then the help output has like 50 parameters, and I still don't know what the tool does. Like, have an example section right at the end, please. Also, exit codes are good to know about. One of the things I think about a lot is that most tools have exactly one way of working and 10, 12 different ways of not working. And it's sometimes really useful to be able to differentiate between those two things. Have your tools say exit code 2 means I failed in this way. Exit code 3 means I failed in this different way. And then when people integrate your tools in scripts, that means they can differentiate between those different situations. Bit of a hot take, banners, please don't. I love the project discovery guys, I really do. And I love ASCII art, I really do. But if you're going to use tools in scripts, it's just kind of annoying. Put it in your GitHub README, not in your tool. When you have parameters, as you will do if your tool does anything reasonably complex, have both long and short. Short parameters are very useful for interactive use when you get used to the tool. Long parameters are self-documenting in scripts. Code is, generally speaking, write once and read many times. And you do yourself a lot of favors to make it easy on yourself when you come back to read things. Also, if you're doing things like HTTP stuff, especially, steal parameters from other tools. A lot of people know how to use curl already. They know that it's dash big H for adding a header, for example. If you have the same functionality, use the same parameters if you can, and people automatically know how to use your tool already. When you're approaching problems, this is something that I think a lot of people do not do. And I've had judgment for doing it this way. When I encounter a problem, my first thought is usually I should go and look that up, but I don't. Try and solve the problem yourself first. And it might be that the solution you come up with, if you come up with one, is actually better than what everyone else came up with before you. It doesn't happen often, but it does happen sometimes. And I found that if you look at somebody else's solution first, it actually becomes more difficult to think of a different solution. Like your brain has been poisoned by the existing information that's out there. Also, really good practice for when there isn't a solution. Nobody else has solved that problem before you. You will inevitably encounter things that you do not know. But do not fall into the trap of learning instead of doing. I talk to a lot of bug bounty hunters who say, oh yeah, I'm doing this training course, I'm working my way through like the Portswigger Academy, and when I've done that, I'm going to start bug bounty hunting. You'll never start. It's one of the best ways to procrastinate. I advocate for just-in-time learning. I encounter a problem, I'm going to go and read the things I need to know in order to solve that problem right now. Also, it's the future. We can Google for stuff. I think a lot about the types of knowledge. You have known knowns, known unknowns, and unknown unknowns, which make up the vast majority of human knowledge. Things you don't know that you don't know. But because it's the future, it's a really effective use of your time to spend time shoveling things from unknown unknowns into known unknowns, because that category is also known as stuff you can Google for. I think there's also a lot to be said for this idea that not knowing that you can't do something is sometimes an advantage. It's kind of an extreme example, but there's this guy, handsome, isn't he, called George Dantzig. And he, somewhat famously, solved two great unsolved problems in statistics because he thought they were supposed to be homework. He came late to a class, they were written up on a chalkboard, he wrote them down, took them away and solved them, and then gave them back to his professor who said, what the hell? I assume. Paraphrasing. But you see this all over the place. This is a little bit of an outside reference, but when I was younger, I used to do a lot of skateboarding. And one thing I've noticed is that kids who grew up playing Tony Hawk's Pro Skater are way better at skateboarding because they didn't know you weren't supposed to be able to do the stuff in the game, so they just tried. And for some of them, it worked. I really encourage you to look at tools from other disciplines, to read outside your area. This is a big niche in which we find ourselves. Security is a big niche with many other big niches in it. Bug bounty is one of them. Really tempting to be reading bug bounty blogs, hacking blogs, and that kind of thing. But that will give you a really narrow view of the world of software and tooling. There are tools for data analysis, for example, which would be probably very useful to us. But if you never read outside your area, you won't find out about them. These things, by the way, long reach forceps. They are a medical tool, but if you ever drop a screw inside a crankcase, they are a lifesaver. Way better than tweezers. You also shouldn't predict what you're going to need and try and prepare for that situation. I think a lot of us are conditioned to believe that being prepared is important. But software is infinitely remoldable. You can change it. You can delete things. You should optimize for things to be changed when a new need occurs and to make them as useful as soon as possible. This image is a bit cliched now. It gets used for like agile versus like waterfall propaganda and that kind of thing. But I genuinely love it. I think about it a lot. Because I think this is the way to do things. Do the most simple thing first and then iterate on it. Copy and paste things. You talk to real software engineers, they'll tell you about the dry principle, do not repeat yourself. And I'm like, maybe. Mostly ignore those people. Because when you do that, you almost always get it wrong if you try and guess what you're going to need in the future. So don't guess, just wait. And to demonstrate that, this is the first version of Gron. So Gron's that tool that turns JSON into greppable lines, and it's written in PHP. And that's literally almost all of the code. I had an immediate need for something. I was looking at an API, and I was getting about a megabyte of JSON back, and I was interested in one particular value somewhere in the middle of that big bundle of JSON. And I was like trying to scroll to it. I have a tip for that. If you have like a regular mouse with a scroll wheel, you turn it upside down, and you drive it like a toy car. You've got to scroll a long way, very useful. In this case, was not working out for me. So I wrote this PHP, hacked it together, and I put it up on GitHub, and a few other people used it, and that was great. Then later, I encountered that problem again, but the PHP version was a bit slow, and someone else who wanted to use it didn't have PHP installed, so they couldn't run it, so I rewrote it in Go. I also wanted to learn Go at the time, so that was useful. Then I got more features. As I encountered more problems, added more things. Someone pointed out, actually, I've grepped a bunch of stuff out of this JSON. It'd be really nice if I could now turn it back into JSON. So that got added. And now somehow it's in the default repos for Ubuntu. Like if you fresh Ubuntu install, you can apt-get install Gron and it works, which is absolutely surreal to me. One thing I get asked a lot is why Go? And one of the reasons I use Go is that, like I've just mentioned, distribution is easy. It's a language that kind of clicked with me. And also concurrency is not that hard. I deal with HTTP a lot. And HTTP means a lot of waiting around. Network requests take a long time. And computers are very, very fast, so we should be doing something else while we're waiting, like firing off more HTTP requests. Also, I'm not that smart. There's this quote from Rob Pike, who worked on Go and UTF-8 and Plan 9 and a bunch of other things. And it gets bandied about, and people get really angry about it. I'm going to read it to you. So the key point here is that programmers are Googlers. They're not researchers. They're not capable of understanding a brilliant language, but we want them to build good software. So the language you give them has to be easy for them to understand and easy to adopt. Now, if you ever spend any amount of time on Hacker News, and I don't recommend that you do, you will find people who put themselves firmly in the camp of people who can understand the brilliant language. And therefore, Go is bad, and we should write everything in Haskell, or Rust, or whatever language it is. Fine. I'm the other way around. I love this because I don't consider myself somebody capable of understanding and fully utilizing a brilliant language. But I also think that the constraints that it gives me actually inspire creativity. A blank canvas is difficult. Like I once tried to design my perfect house. I got a piece of paper and I was like, oh, what shape should it be? I don't know. Well, when you've got an infinite number of options, it is almost impossible to pare them down. And I think that's actually one of the core components of hacking for me. Everything is constraints when it comes to hacking. I have this parameter and it only accepts these particular values, and I need to make this system do this particular thing and work with this other chain of bugs that I've got. It's all about constraints. And that allows me, at least, to come up with better solutions through being limited. I've been asked why I write open source software. And the answer is I want to give back. Nearly all of the tools I used, Vim, my operating system, until I bought a Mac, was open source. I feel like if other people hadn't done that, I wouldn't be where I am today. But also, one of the best ways to have a tool that you need appear as if by magic is to write a bad version. And people will be very angry about this, and they will prove to you that they can write a better version, and they will release it, and then you can use their version. It's maybe a cynical way of thinking about it, but genuinely, some of my favorite tools are things that other people wrote because my tools weren't good enough. I wrote a tool called Wayback URLs. It's okay. It fetches a list of URLs from archive.org. There are other sources of that data. I started to add them. I couldn't be bothered. A guy called Corbin went and wrote a tool called GAU, Get All URLs. It's much better. You should use his tool instead of mine. I do. And also, I don't have to feel as bad about maybe not being on top of all my pull requests. Also, there's this tweet on the right. And yeah, I'm going to call them tweets. They're still tweets. And this is the Ubuntu account congratulating the Fedora developers for releasing a new version of their software. And beneath it is a reply from someone who says, "Aren't you guys competitors?" And the reply from Ubuntu really struck a chord with me. I think it's beautiful. It says, "The world is big enough for us all to succeed. We can honestly celebrate the achievements of others in the free software community. They're our friends, after all." I've also been asked, like, why do you have a job? Shouldn't you be, like, freelancing, maybe full-time bug bounty? And the honest answer is that sounds incredibly stressful. If you can do it, great. I admire you, but I can't do it. I did, however, pick an employer that was good about open source software, that let me continue to work on open source tools and release them, albeit under their name. But also, they picked me because of my tools, which was kind of weird for me. I wouldn't be where I am now if it wasn't for releasing these tools into the wild. Being on a team in an employer also allows me to do something that I never really gave myself permission to do before, which is to work on my strengths. I was always of the opinion that I need to spend the most amount of time working on my weaknesses. And it turns out that's silly, because my weaknesses are the things that I'm not very good at. If I spend time working on my strengths instead, that is a force multiplier, and I can become very, very good at something instead of becoming mediocre at something I was previously not that great at. Being on a team means I can use people to stand in for my weaknesses instead of a great deal of effort. Also, I get asked how to exit Vim. I used to use Notepad++. Here's how you exit Vim. That is the one true way. I started using Vim because I was forced to. I used to work with Notepad++, editing, over a Samba share, and then I had to do some work on a server at my job, and Samba would not work. It seg-faulted. So I use Vim. Was there for a few weeks. I never went back. I'm also a lifelong imposter. Like, I'm not entirely convinced that I am qualified to be up here telling you about how to do things. But then, fortuitously, I saw this post from James Kettle, or Albino Wax. For those of you who don't know, this is a guy who works at Portswigger, makers of Burp Suite, and he releases basically the most impactful research in web security year on year for a long time. And he's here saying, every year I was worried my next research project would be my last. And like, this is one of the smartest people I've ever met, thinking he's not good enough. And I really related to that. And I think you should be more mindful of what other people say about you, about the nice things. Because if someone says something nice about you, and you say, no, you're wrong, that's kind of insulting to them, don't you think? I also have a real fear of missing out that took me a long time to get over. I've come to think of myself as a bug bounty blacksmith. You lot, most of you, you're the knights. You need to wield the swords, but someone needs to make them. And it's okay to be that way. It's difficult to be that way when you're on social media and people are posting about the 40K they just got for the RCE that they submitted. Really difficult, especially if they say, I used your tools to make this money. I think, damn, I should use my own tools. But you can't do everything. This is a big niche, so you should find the things that you enjoy the most, and you should focus on them and not worry too much about the things that you are missing out on. And generally, you will be tempted to compare yourself to other people. And the people who are the most visible tend to be the people who are very, very good at things, and you should not do that. I spent a long time doing that myself. This thing, this shape, the long-tail distribution, this is everywhere, especially on leaderboards. The top 1% are so much better than everybody else, and they're the people that you'll see. Do not compare yourself to them. In particular, it's very easy to think about the max observed value of things. You think, I saw someone get $100,000 for a bug bounty, and I only made $500. They are 20 times better than me. Well, that's the wrong way to think about it. You are better than 99% of people, because 99% of people have not got any bounties at all. Also, when it comes to skills and things, it's actually pretty easy to get yourself into the 90th percentile at something just by trying a bit, because most people don't even get that far. And you can do this wonderful thing of skill stacking. If you're 90th percentile for two things, mathematically, you can be 99th percentile for that combination. You're 10% of one and 10% of the other, 10% of 10%, 1%. 99th percentile. Add another one, you add another 9. And quite quickly, you can make yourself actually really, really good at your particular combination of skills. World class, in fact. You might worry about being uneducated. I'm uneducated. Or some people will refer to that as being self-taught. But somehow I have citations against my handle in Google Scholar, like there are actual scientific papers that reference tomnomnom, which is actually just kind of hilarious. So don't let that hold you back. But also, you should really take this advice and the advice of any other successful people. I think by any objective metric, I have to consider myself at least a little bit successful with a grain of salt. There's a lot of survivorship bias with advice from successful people because they are successful. I get up at 4 a.m. every day, do yoga, and then I have a disgusting smoothie, and then I go on LinkedIn and post about how good my life is. There are people doing that the world over who are not successful at all. You need to be aware of that. Luck plays an enormous factor in all of our lives. So, you want to get into writing tools, and you don't think you're much of a programmer, that's okay. Next time you have a fancy one-liner, some complex command you came up with, even a simple command, put it in a shell script. Congratulations, you are now a programmer. If anyone tells you differently, send them my way. I will correct them for you. If you add in learning a little bit about variables, about conditionals and loops, you will be able to write probably 90% of the custom tooling that you need. And you are now a programmer. Congratulations. You should also make yourself a hacks repo. This is a repository of mine that I created on GitHub for the purpose of putting up one-off scripts that I'd written, tools that weren't finished. And it lowers the barrier for publishing things. Even if no one ever uses it but you, it's still useful to have when you get yourself a new laptop and you need to find that script that you used once. But lowering the barrier for actually publishing code, whether you think it's bad or not, I think is an incredibly important thing to do. Some of my best tools started here. I wrote them. Someone else said, hey, I found this tool in your hacks repo. and it was really useful. And then it got its own repo, and it got a README, and it got a help output, and all of those other things. At some point, you might write something that becomes successful. And one of the things that took me a really long time to get good at, and I'm still working on, is saying no to other people's ideas. People will come to you and say, hey, I like your tool, but it would be even better if it did this too. And because you want to be good and to be loved, you say yes. But you make your tool worse in the process. And before you know it, you've got an Ultron tool instead of an Iron Man tool, and that's not what you wanted. It's okay to say no to people if their goals don't align with yours. But mostly, go out, make tools, and share them with the world. Thanks. Have we got time for questions? What, did I run over? In your clearest English, please, because I am English, and I apologize for that profusely.
¿El otro micrófono lo tienen por allá, de casualidad? So, ¿quién tenía la pregunta?
Si no me pongo nervioso suficiente, me va a entender. Hello. First of all, I want to thank you for your tools. And later you mentioned some of the programming rules as Shagny and all of that. And so I want to ask you for the keys one, keep it simple, stupid, because it was one of the steps in the programming progress, one of the diapositives you show. And one of the steps was to find the simplest way to do a thing. And so that's my question. How about to the keys and keep it the thing simple?
How to keep things simple? It's actually a really difficult question to answer. Keeping things simple is actually a pretty complicated thing to do. Ironically. And that quote that I had up earlier, I think is a big part of it. Of perfection is not achieved when there's nothing left to add, but when there's nothing left to take away. You want to keep something simple, start complicated. Because the simplest solution is not necessarily the first one you arrive at. Really, I think programming should follow the steps of make it work, make it fast, make it elegant. Maybe swap those two around, or make it simple, whichever it is. And that sometimes making it simple is the most difficult step, because you have to be prepared to throw things away. And sometimes you have to be prepared to make logical leaps about things. But yeah, I think my general approach is write a complicated version, copy and paste things, make it work, and once it works, see how you can refactor things, how you can take things away. That's how you really end up with a simple solution. But maybe that's, after the second time that you need to solve that same problem. Good question, thank you.
Thank you for the question. ¿Alguna otra pregunta? Yo le puedo... Bien, allá hay una más.
Hi, thank you for the talk. I really like it. I'm also a big fan of tools. I would like to know how you feel about LLMs, because I'm all the time, instead of creating new tools or learning to use tools, I'm all the time asking the LLM, how do I do this, and just copy-paste that. I'm interested in how you see it. Thank you.
Yeah, good question. Mixed feelings, I think, is probably the best answer. Not so long ago, I spent about 30 minutes trying to figure out how to do a particular thing on the command line. And when I'd worked it out, I went and asked ChatGPT how to do it, and it gave me the answer straight away. And that was kind of depressing, because I was always the guy at work that people would come to ask those kind of questions, and now they don't have to. But the other side of that is I'm excited because there's a whole bunch of problems I've tried to solve in the past that I failed to solve because something was too difficult. So a really good example is when you take things like a subdomain, and it might be like the brand name and then the word dev and then a number .example.com. Splitting that up into tokens, I worked on that so many times, like trying to do like what are common words, knowing what the brand name is, writing traditional code to solve that problem is a fool's errand. But LLMs make that kind of possible. Even if you just take the tokenization side of an LLM without all of like the reasoning and inference side of stuff. So at the same time, I'm excited because it makes some things more possible. In particular, classification tasks as well. Things like, what kind of web app is this? I've got a list of 100,000 URLs. I want to know which ones are e-commerce sites, which ones are admin panels. Like I've written really, really long grep patterns to try and figure out, is this thing an administration panel? And it's never finished. But I can ask an LLM, is this an administration panel? And it kind of works. So mixed feelings. Thank you.
Cool. I have one. So obviously, I love your approach. This was an enlightening talk for me, right? And I wanted to know how and when do you come up with the names of your tools? Because
right when I need to make the directory for the GitHub repo is when. And they are a mixed bag. So either they are portmanteaus, things like gron, which is grep and JSON, very clever, or they are short initialisms, things like FFF, the fairly fast fetcher, or like there's not really much of a scheme to it as well, because we also have comb, and that is named for like a hair comb, because I imagine two combs with the prongs being interwoven as like an example of what it does. Naming things is one of the two hard things in computer science, along with cache invalidation and off-by-one errors.
Perfect. Thank you so very much. Well, huge round of applause for Tom here.
Thank you.
Amazing talk. Thank you very much.